question?
Okay, I have to remember to unmute.
Please.
I think we can start with 15 persons, and whoever join will think, so that we can be on time, because we have carded an hour and a half for the session. So I think we can go ahead and let them in start.
Okay, so we can start, right?
Yes.
Okay, so let's start then. Good afternoon and welcome to all to our third session of a series of technical sessions aligned with the strategic plan we crafted together last November during the VHL network meeting held in São Paulo. This plan aims to strengthen the MedCarib network and cooperatively build the Caribbean VHL. Hope this session will be valuable, and please feel free to ask questions and share your insights whenever you want to. Today, we will have the opening remarks by Victoria Cruickshank-Taylor, the regional coordinator of the MedCarib network. And in the context of document indexing according to LILAC's methodology, we will have two presentations from BIREME, from our BIREME's colleagues. One presentation will be about the DeCS 2024 edition with Cristina Espíndola Campos, and the second one will be about exploring semi-automatic indexing with lexical and artificial intelligence tools with Sueli, Mitiko, Yano, Suga, and Luciana, Beatriz, PiovezanRio, Branco. Okay, so we will open for questions and comments, but you feel free to use the chat if you prefer. Okay, so let's start. Victoria, would you like to say a few words?
Yes, thank you so much, Márcia. Good afternoon, everyone, and thank you so much for being here and being on time. Once again, we would like to thank BIREME for ensuring that they do their part in making sure that the Caribbean, English-speaking Caribbean network has its strength and power. Now, I want to just say that I have invited a few students from CUSTAT, that is final year students from CUSTAT, who is doing their degree in library science, and incidentally, their thesis is, all of them would be on using AI in libraries. So I thought that this would be a good opportunity for them to get some real life exposure on what happens in the industry. So welcome, because as from CUSTAT, CUSTAT is also a member of the network, and we are hoping that as they are exposed to what we do, that they will see the need to continue to give back and explore being a part of the network. So I thought that this was a good opportunity to bring them in. So welcome. And I know we would have a very fruitful and interesting discussion. Make use of the opportunity, ask as many questions as possible, as I know that it will be enlightening. Thank you so much.
Thank you, Victoria. Thank you for your introduction words. And we are very pleased to have the CUSTAT students here also. So welcome to all of you. And to start with, we will have the DeCS 2024 edition presentation with Cristina Espíndola Campos. Ana, please.
Good afternoon, everyone. So I would like to share my screen. Is it okay? Can you see
Yeah.
it?
Yes.
Yes.
Yes,
Yes.
yes, we
Thank
can
you.
see your screen.
So I'll show you some of 2024 DEX mesh updates. Personally. Well, so DEX Mesh is one of BIREME products, one of the most important BIREME products. It is used for indexing the articles and documents in LILACs databases, and which are in a virtual health library, which is one of our products as well. What is DEX? DEX is the acronym for Descriptores em Ciências de la Saúde, Health Sciences Descriptors, which is a controlled vocabulary produced by BIREME since 1986 that is updated every year together with MESH. The terms of the vocabulary are hierarchically organized. It is used to index articles, theses, dissertations, and other types of technical scientific documents. It is used by VHL searchers, librarians, students, scientists, policymakers, and so on. As it is a dynamic vocabulary with a never-ending process of growth, changes, replacements, and the creation of new terms or areas, it is yearly updated. So DEX is also multilingual. It means that every content in Portuguese is also seen in Spanish, English, and French. It includes the translation of MASH, which is medical subject headings from National Library of Medicine of the United States. And it is the full translation of its terms and its subject categories. But it has 5 more exclusive categories, which are science and health, homeopathy, traditional complementary and integrative medicine, public health, and surveillance in public health. Well, where is DEX available? DEX is available at DEX Mesh website and in VHL website. Here in VHL homepage, there's a button in which users may search for DEX Mesh descriptors. Well, the DEX Mesh website is very friendly for use, and it has 5 types of search. Here in the left, there are 5 types of search, and the user may enter the text to be searched here in this yellow field. Well, DEX comes from MESH, which is medical subject headings, and MESH has 16 subject categories, which are represented by one single letter. And so just to visualize how DEX incorporates MESH. MESH has its 16 subject categories, and DEX has 16 categories from MESH plus 5 exclusive categories, which are here represented by 2 letters in green. So DEX has 21 subject categories with these 5 exclusive categories: homeopathy, traditional complementary and integrative medicine, science and health, public health, and surveillance in public health. Well, DEX structure is, I believe, the most interesting part of DEX, which is thesaurus. So I think this structure is really a treasure. Its 21 categories are divided in first level subcategories, and each subcategories are subdivided in many descriptors. So from the second level to infinite levels, there are the many descriptors. Just an example of how the subcategories are organized. We are going to use organisms category, which has 5 subcategories, and under eukaryota, we can see it's 9 children, which are the descriptor under eukaryota subcategory. Well, DEX contents, as it has already been said, the same content is in 4 languages. So we have in Portuguese, in English, which comes from MESH, most of them, in Spanish and in French. Well, now DEX records are very easy to understand as well, but I'm going to get an example of a new descriptor for 2024, which is deaf culture. So if we enter deaf culture in a search field with search type any term or exact term, we find the record of this descriptor. So here in highlighted in dark green, we see the descriptors in 4 languages: English, Spanish, Portuguese, and French, depending on the language of the user's interface. The entry terms, which are synonyms or terms used to be represented by the descriptor. And then the tree codes or tree numbers. Then we have the scope node, which is the definition of the concept, and allowable qualifiers and the descriptor unique identifier. These 4 highlighted here are the search possible for being entered at the search field. Here at the right side, upper right side, we have the Spanish from Spain. If we click on this button, the descriptor, the entry terms, and its scope node, also in Spanish from Spain, are displayed. Well, another tab in the index records shows the tree structures of the descriptor record, and this is the most interesting part of DEX, in my opinion, because the user may navigate in such a structure, and the points of the tree in which the descriptor is located are shown. So here, in this example, deaf culture has 3 codes, tree codes, and here it's shown 2 of them. 2 of them are being shown. The next tab is the tab concepts. So the concepts show the preferred term of the record and then the synonyms or entry terms. In this case, deaf community is deaf culture synonym. So it means that the concept deaf community is represented by the descriptor deaf culture until in a future mesh edition it may be detached as a new descriptor. So not necessarily the entry terms are synonyms per se, but they can be very nearly related concepts that someday may be detached as new descriptors. Well, finally, 2024 mesh index updates. I'm going to talk about some highlights in numbers and increases. Then there are some mesh special projects, which 4 are highlighted, and 2 of DEX exclusive categories from projects are going to be shown. Well, this year edition, we had 311 new descriptor records from mesh, and 83 descriptors were new to DEX exclusive categories. The new descriptors for 2024 were distributed by all these categories, and the category chemicals and drugs was the one which received more descriptor records. Chemical and drugs category is also the one with the biggest number of descriptor records, followed by diseases category, organisms, techniques, processes, health care, and public health. And notice that public health is among the 10 top categories, and it is one of DEX exclusive categories. Well, this table on your left shows the amount of descriptors, synonyms, and terms in English, Spanish, Portuguese, and French. And altogether, English, Spanish, Portuguese, French, plus the idiomatic variant of Spanish from Spain, index, we have more than 729,000 terms. So this number represents an increase of 0.8% of DEX when compared to DEX from last year. Well, now I'm going to talk about mesh special projects. The first of them is some terms of psychological stress, which were added to the vocabulary, including coping skills, emotional exhaustion, financial stress, job security, media exposure, medical neglect, psychological growth, safety and resilience, role conflict, subjective stress, and time pressure. Also, Latin binomials were replaced some common names in the category B, organisms, and new descriptors of living beings were added in that format. It is something that we have been seeing lately. Some examples are gamma influenza virus, Glycine max, Lactuca, Nicotiana, and Ricinus communis. Also in B category, organisms, a new mesh term, venomous snakes, was added to help finding snakes from Elapide and Viperidae families with this feature. So in previous DEX editions, Elapide and Viperidae were only under Alechinophidia, and now from 2024 a mesh edition, Elapide and Viperidae snakes are also under venomous snakes. So venomous snakes is a sibling of Alechinophidia, and both have Elapide and Viperidae families of snakes. Also, a special mesh project was adding of voting in social science subcategory, which was removed as an entry term and turned into a main heading, which is treated under the term politics. So now politics has 6 children, and voting is now a descriptor. Well, now I'm going to talk about DEX special projects. The first one is inclusive language. This was a special project mainly in Portuguese, and I believe this 2025 edition of DEX, some of Spanish will be as well completed. And because some descriptors in Portuguese had ableist biased scope notes or were themselves biased, and they were revised. As a result, 7 new descriptors were added or corrected, 35 new alternative terms were added, 57 terms were removed. And to those that were maintained, a specific note was added to their scope notes, indicating that there is a potential ableist bias for the purpose of retrieving historical literature only. So they were kept just for retrieving literature. Another special project for DEX was the homeopathy category revision, in which many changes were made. Um, for instance, terms were migrated to other records, changes of the descriptor, of the name of the descriptors, new records were added, some records were deleted, many changes on their scope notes, but the main change was in hierarchy. Then we can see here that the homeopathic remedies that were then organized by were alphabetically organized, now are organized by origin. So they are homeopathic remedies of plant origin, which are the most of them. Nosode or sarcode, animal, bacterial, fungi, chemical, virus, radiation, and organotherapeutic origin. So just finishing now, I would like to tell you that here in DEX Mesh homepage, there is a tab for developers who may wish to get updated XML files for download or an API token for web services, both of them under a license agreement. That's what I wanted to say. Thank you very much.
Thank you, Ana Cristina, for this very, very informative session, talk. And well, I don't know if you have any questions now or if you prefer to have them in the end. Okay. Okay, so let's proceed. And now we will have exploring semi-automatic indexing with lexical and artificial intelligence tools with Sueli and Luciana. Please.
Good afternoon. Good afternoon. Thank you, Márcia. And congratulations, Ana Cristina, for your presentation. What we are going to present now is a result of exploration that we are doing adopting tools to support the document indexing process. We designed, Luciana and me, all the study, and we count with the help from some Lilacs indexing network members that proceeded the tests in each tool. So just for you to know all the agenda of the presentation, just let me change here to see better. Yes, just to know the agenda of the presentation, we're gonna present an introduction. After the methodology we developed to proceed these tests. And we have developed with the help of another BIREME collaborator called Danilo Appendino, who developed the prompt we used in the artificial intelligence tools we have tested. And now we are presenting for you the preliminary findings the tool performance, a comparison with the manual indexing, and the feedback, the comments that these indexers did about these tools. And we have some considerations about the limitation of the test and areas for improving not only the prompt, for example, but some ideas that we can start doing from now that we have these results of this study, and a time for questions and discussion about the results. First, I just want to talk about where we are from where we are starting. We are talking about Lilacs methodology, and when we talk about Lilacs methodology, mainly we can think about Lilacs indexing, the process of the document indexing in Lilacs. And this is a process for synthesizing the content of the document and selecting the appropriate terms from DEX mesh vocabulary. And this approach is really depth indexing and more comprehensive. And then when we have to index an article, what we expect as a result of indexing is a very specific and precise descriptor from the content of the document, adopting and dividing the indexing in primary descriptors with subheadings, and secondary descriptors, the description of the human, the subject of the research, and the type of publication or this study design of the study. Okay, then what we are doing now, changing the paradigm, from the manual to a semi-automatic, or in the future, automatic indexing. Why we are doing this? What we expect from this change in the process? We'd like to reduce the processing time of large volumes of documents. I believe not only here at BIREME, but in your institution. Probably you have many documents that are waiting to be processed and waiting for being indexed, and then it's bad because we don't have the databases updated, and most part of this time they are incomplete bibliographic records. Another thing that we expect is to minimize the inconsistencies between indexers, ensuring uniformity in terms. Automatic suggested terms can be reviewed and adjusted by professionals. Because of this, semi-automatic, just for now, facilitates the incorporation of new terms and adaptation to changes in controlled vocabularies, and reduces the risk of human error. Then the objective of this test is to explore, test, demonstrate the use of lexical, semantic, and artificial intelligence tools to support the document indexing and adopting Lilacs methodology. Then it's not a general indexing, but a more comprehensive indexing. And why now? All of you know, all the changes we are facing in this technological changes we are facing now, and the large volume of the data and information we have to process, and the need to respond faster to the requirements, the needs of the users, and there's no way more to to be where we are just doing this work manually. In terms of the thematic indexing, we already know that the presence of the subject descriptors will facilitate the retrieval of the information, but not only this. The semantic analysis will help for the machine to read and understand and process these records. No, then because of this, we are doing this now and proceeding this test. Just for understanding what we are the concept we are adopting for lexical tools, semantic tools, or artificial intelligence tools. So lexic tools are based on exact word or terms matches without understanding the text meaning. So it's usually used for simple and with less need to contextual interpretation. Semantic tools aims to understand the context and the meaning of the tools, enabling a deeper interpretation and identification of implicit themes and concepts. And the artificial intelligence tools combine lexical and semantic capabilities with learning, improving their performance over time and providing a more versatile and advanced solution for complex language processing tasks. We just made this table to help understanding the difference from these kind of tools. I just wanna proceed for not being so late. Then we have classified the tools we are analyzing, and BIREME is the developer of the tool called DEX Finder. That is a lexical tool, and this performs a direct matching searches for DEX terms in the text without considering the context. Then when you copy and paste a part of the document or the title, the abstract, and click the button, you will receive a list of DEX descriptors as a suggestion to describe or the content or adopt as keywords for the article. The same idea, Mesh on Demand from National Lab of Medicine, is mainly lexical, but in some parts of the processing, there is an AI automation. The same idea, you copy and paste the text and receive a list of mesh descriptors. ANIFI is an artificial intelligence and semantic type of tool. Utilizes a combination of lexical and semantic methods with AI, and it can evaluate the meaning of the text and suggest relevant descriptors. Luciana is the person, the collaborator here in BIREME, that is responsible for adapting this tool and she's leading the process of training the ANIF with DEX descriptors in this moment. Maybe she can talk a little about this. And we are using GPT, Gemini, and Copilots. They are not tools specific for document indexing, but if we apply a specific prompt for document indexing, we have succeed receiving suggestions of descriptors for all of these tools. Then ChatGPT GPT uses a language model to understand the context and the meaning of the words, enabling semantic analysis and generating text-based generating text based on prompts. Gemini, similar to ChatGPT, it uses AI to understand the context and meaning of the text, offering semantic analysis for various use cases. And Copilot is primarily an AI tool for assisting with code generation and text suggestions, and can perform semantic tasks when applied to natural language processing. I will just skip because we have okay. Now, how we worked in this study? What's the methodology? This is exploratory and qualitative study, and this is this is the initial preliminary results we are presenting. Okay. We defined 10 documents to represent the different health areas, and we created 2 questionnaires, and I'll talk a little more about of it. But the objective is to evaluate the indexing and the tools. And we have standardized procedures because we are working with 3 testers, and they are from different institutions with different experience, and then we have to standardize it to receive the same result from them. And in the final, we have a comparative evaluation with DEX, if they are DEX descriptors, if they really are DEX descriptors, if the content that the tools offered really are in the document, and finally, if they are discussed in the document. What we usually do when we are doing manual indexing. We only assign descriptors that are really discussed in the document and not only mentioned. About the corpus definition, so I have already told you that we selected 10 articles, and the selection criteria was the thematic relevance. All of them are related to public health and primary care attention, and some of them have specific indexing rules that should be applied in the indexing. We already thought about the thematic diversity, and then we have many different types of population included. Significant contribution or potential impact on professional practice and health policies, and methodological quality. All the articles are from journals that are in peer-reviewed journals indexed in Lilacs. Here the list and the areas we have included. The list of the documents, the articles. We needed to only choose Portuguese articles just because we are testing another tool called CISA. But in the end, we needed to exclude this tool for other time to evaluate. So the areas that we have included are nursing, dentistry, psychology, traditional, complementary, and integrative medicine, neoplasms, public health, tropical medicine, epidemiology, drugs and chemical compounds, and cardiology. This test reviews mainly the identification and assignment of thematic descriptors, the fidelity of to the DEX descriptors, if the the subjects really are DEX descriptors or just an alternative term, for example, or synonym. The challenges in the indexing complex topics, you all know that sometimes we spend many time trying to understand the content of the documents because they are really complex, and one of the objectives is to understand the content faster. And then because of this, we are thinking about this result in the end of this study. The criteria for evaluating the quality of the automatic indexing, just the stage when we are creating the questionnaire, it was not easy because most part of the time we see in the literature only quantitative studies, but in our case we are trying to evaluate the results qualitatively. Then we created these questionnaires, and in the end, we expect to have a proposal for a hybrid methodology for document indexing. Unfortunately, I cannot show the questionnaire now because we have to translate it for English, but the objective of the first questionnaire was to evaluate the knowledge of the indexers that are using these tools, evaluate the performance of the tools, and before indexing the documents. And in the phase 2 of the test, after the indexer will index the documents, and then proceed to respond the second questionnaire. We have 72 answers to all of these 3 indexers and seven tools. And we designed a prompt for interacting with these IA tools. And for this design, we already know that it must be clear and objective and show a good instruction for 4 elements: the objective, the context, the source, and expectation. And as a result of this creation, the objective is index this article, context using descriptors and qualifiers from DEX Mesh Thesaurus, and here the full name of the product. The source, use articles indexed in Lilacs database as a reference because of Lilacs methodology, and the expectation is to present the results in DEX/qualifier format when there is a qualifier separating the primary descriptor from the secondary ones, both with their qualifiers. And when we are making the first tries, we added more information to divide the content. Then we included the type of the publication or study design and the subjects of the research. And the final result, as an example, we have here the first part where we give the instruction and the information about the article, the title, the abstract, and the keywords in Portuguese and in English. And as the first result, I guess this is from ChatGPT. We have the indexing proposed and divided with main descriptors, secondary descriptors, type of publication, and subjects of the research. Talking about the characterization of the indexers, all are members of the LILACS indexing network and has experience in a lot of experience, in fact, about adopting and using LILACS methodology in indexing. Talking about the artificial intelligence routine, using in the work routine, one of them use it frequently, the other one occasionally, and one of them never uses this kind AI tools. Use of support tools for indexing, if they already adopt one of these tools, and then we just can see here that 3 of them adopts mesh on demand and makes searches in VHL or PubMed portal to identify and select descriptors for indexing. About the frequency of use, of course, an if is a new tool, and then it's not adapted with DeCS vocabulary, and then none of them use this tool, and neither Gemini. What we have is Mesh on Demand and DeCS Finder are occasionally used, and ChatGPT occasionally used also. Now talking about if the prompt worked for the 3 AI tools, we see here that only once in Gemini we have problems on the division of the types of descriptors. All of them, ChatGPT, Copilot, and Gemini, in almost all the time, presented the content or the indexing divided. Talking about the tools, and here I included the answer of 3 questions. If the tools really adopts or suggests this DeCS descriptors, and you can see here, maybe this is an error from the indexers that are responding the answer or the question. Mesh on Demand and DeCS Finder are expected to have 100% of coincidence, but probably we'll have problems or in the tool or in the response, the answer of the indexer. Okay. An if, as I told you, was not adapted with DeCS vocabulary, and then because of this have the only 51% of a coincidence with DeCS descriptors. And interesting thing is that ChatGPT in 75% of the times are suggesting DeCS descriptors. Here in the orange part, we have the suggestion of terms that really are concepts that are in the document, independent if they are DeCS descriptors or not, independent if they are really discussed or not. And then we have here Copilot as the tool with better result. In 90% of the times, they are offering the subjects that really are in the content of the document. And the last part here is the after the manual document indexing. Then the indexers evaluate if the suggestions, the terms suggested really could be adopted in the indexing because they are discussed in the content of the article. Then we have here Copilot, ChatGPT, and Mesh on demand with 65% and 66% as a result. Talking about the areas, we have here drugs and chemical compounds and epidemiology and public health with the more than 80% of coincidence with DEX descriptors. Talking about the content, here we have drugs and compounds with 100% and tropical medicine with 100%. And then all the terms that was suggested were from the tools really are in the document. Epidemiology also has a good, cardiology has a good result. And in the end, after manual indexing, we have tropical medicine, epidemiology, and drugs and chemical compounds as terms that could be applied because in the indexing because really are discussed in the document. Here, just a view about the percentage of the subject suggested by indexer. Then we can see the third indexer was a little more, I don't know how to say this. He accepts more the suggestions of the tools. Talking about the response time, here we can see in red, Mesh on Demand have more than 120 seconds to respond, up to 120 seconds to respond. Then really Mesh on Demand is but if we think about, there are just 2 minutes, but we are so used to have immediate response that when we have to wait for 2 minutes, we are impatient about the results. And here we have 2 answers in Copilot and Gemini when they have more than 2 minutes and up to 2 minutes up to 1 minute to respond to the question we have included. But we believe that it was a problem in the tool, but because in all the other questions that tests they are done, we have or immediate or up to 10 seconds to respond to the question. And just to see the response time, probably here we have a problem in the response because ANIF is very fast. But here we can see once Mesh on Demand highlighted as an unsatisfied or completely unsatisfied with the tool. Talking about the tools utility for each stage, in each stage of the document indexing. For content analysis, we have here unsatisfied as the most frequent response. Extraction of terms and concepts for indexing. they consider that the tools are useful for this. Synthesizing and selecting the concepts for indexing. Here, unsatisfied, the most frequent. Identification and translation of subjects into authorized descriptors, they agreed, but also unsatisfied, no? And the last one is the revision of the indexing. Most frequent response was unsatisfied. And the tool effectiveness and adoption in the indexing process. Here we have if the tool is intuitive and easy to use, and I cannot see the percentage, but more than 60% responded, no, 60 answers responded that agree, that it, most part are intuitive and easy to use. If the tool has identified subject that I had not considered for indexing, unsatisfied, then in most part of the time, all the suggestions are concepts that are expected to have to be included in the indexing. The list of subjects provided is useful and have assigned the subjects in the articles indexing. Then we have here agreed. They really assigned the subjects suggested in most 30 times. The tool has reduced the time. And here we have unsatisfied as the most frequent answer. Maybe because most of the tools are new and it's a new process, and then we do not see reduction of time in the indexing process. I'm considering adopting the tool for in my documenting the workflow, and most part answered as agreed, and I'm undecided. And the last one, I would recommend this tool to others, to other indexers, and also undecided and unsatisfied as an answer. Just a table with the comments because we have some open questions about the performance, and then the result is an if the most frequent sentiment was negative, there was no identified key strengths. The key weakness is irrelevant terms, general descriptors, and vocabulary mismatch. ChatGPT mixed to positive sentiment, correct descriptors, good performance, and promising. Key weaknesses, manual review needed, issues with secondary descriptors. Copilot mixed sentiment, learning tool, corrected descriptors in some cases, and confusing coordination, missing qualifiers. For Dex Finder, mixed sentiment, useful for well-prepared texts, helpful for novices. And the weaknesses are general descriptors, limited usefulness. Gemini is a most negative sentiment, intuitive and easy to use. And the weaknesses are incorrect qualifiers and poor coordination. And Mesh on Demand was classified, or the sentiment analysis are positive, concise suggestions, relevant terms. And the weaknesses are large language barrier, no differentiation of terms. The limitation of the tests, they're limited, as I told you, we have just 10 articles and 3 testers and 7 tools. but because of this, we have to consider making another other tests with large number of the articles. Some tools struggled with specialized or multidisciplinary articles where human indexer expertise is crucial. Tests are conducted only with articles in Portuguese, which requires tests with Spanish and English language for performance comparison. And the tests are not completely reproducible, especially when considering tools that use artificial intelligence, as these technologies have evolved rapidly and the responses are based on the knowledge learned from the tools users. Conclusions. The preliminary findings show that semi-automatic indexing tools hold great promise for speeding up the indexing process while maintaining a good level of accuracy. However, they are not perfect and likely benefit from human oversight. And next steps, testing these tools on larger data sets and exploring ways to further improve their performance. Make another test with ANIF with DEX mesh thesaurus included and trained, and continue refining the prompt and instructions used with these AI tools. We have a first draft for a new prompt, but we have not tested yet, but it's just for one of the results of this study. Thank you very much. And I don't know if Luciana wants to talk a little more about, or make comments, but just for you to know, we will present the results of this study in Spanish on October 10th for Latin American network. And then that's the result of the study. Thank you.
Thank you, Sueli. Very, very interesting. Maybe Luciana would like to add some insights.
Well, I would just like to comment that, as Sueli said, the ANIF that was used in this test is not trained, which means the tool used is the trial version available in the ANIF website. We are now training a version of this tool with DEX mesh, and our goal is that it's available all together with DEX Finder. So we could analyze texts and see the results of this semi-automatic indexing with DEX mesh descriptors, and then probably these results would be different. And I think Sueli did a great presentation and explained everything about the study, and maybe the audience would have questions and we could address them. Thank you, Márcia.
Thank you, Luciana. Thank you, Sueli. If someone has any questions, please feel free to do it now. Thank you. Or at least put in the chat. Thank you.
Thank you very much. Hi, this is Victoria. I want to thank you so much for the presentation. It was really very interesting. And I wondered, when you were looking at the response time, did the response time have any correlation with how accurate the outcome of the prompts were? Were you able to look at that? I can't remember seeing it. So some took 2 minutes, some took 30 seconds, but did that have anything to do with what came back as far as what you were searching for? Did that impact it?
No, no. This is the time that the tool lasts for offering the response, but the quality is not related to the time of the response.
So it's not related, or you didn't try to see if it is related or not. It's not related at all.
I understand that not. I don't know, Luciana, but
well, I think for the Gen AI, it can be said that different models, and even if you're using ChatGPT, different models have different times of response because of the technology of them. But for all of them, connection problems and troubles with the internal problems of the structure have more impact on the time. It's not conclusive to say that it does or it does not have a relation with the result. For the subject indexing tools like an if, DexFinder, and Mesh on Demand, it has no correlation with the time and the quality. The result is not variable, which means even if the result is, it could take an hour or 10 seconds, the result will always be the same. It's because it's not an artificial intelligence, so this is a fact. But we can look a little more into this and find out if you can find some in the study. But I guess we won't find any correlation because of the type of study.
Okay, thank you. Any more questions or comments? We have just a comment.
Yes, I also wanted to say, Victoria, again, I also wanted to say that I had hoped that the summary findings of the indexes would have been different, and that we can see the use of these AI tools as being something instrumental in making our work a little easier. But based on the results that came back, I see that indexes still have a lot of work to do. And there is still some time yet before we get to that place. But I find that the fact that you took the time to do the study and to collate the results so that we can have an insight into how these tools perform. I think that was a great initiative, a great study, and it may even give some of us, other of us, things to think about in how we can help to innovate what we do. And I just want to compliment you on that, on the step that you took to do this study and to bring back the results to us. And I know that BIREME, being the innovative organization that you are, before long, we will see something that we can use where AI, where we can have AI as a part of our mainstream indexing process. So thank you so much for taking the time to do that study, to think about it and to actually do it and engage in it. Yeah.
Thank you, Victoria. And Ayana is in the chat saying it shows that we are still to proceed with caution with AI. It's true, very true, right? AI seems to be a very interesting tool for us to use, but we have to do it very slowly and with caution because it's not that AI will replace humans in the near or so near future, right? Okay, so any other question or comment? No? Okay, so how about opening the camera so we can take a good picture of all of us? Victoria, you have to start it, please. Oh, Veronica, you are here. Ayana, nice to see you. Hi. No cameras? All cameras at weekend? Okay. Oh, hi. So let's take a picture. I smile. Just a moment. Hey. Right. So thank you so much for this very insightful presentation from all of you. It was very, very interesting. It makes all of us think about artificial intelligence and the use of it in also in our lives, right? So hope to see you again in our next session. See you. Bye-bye.
Goodbye, everyone.
Bye, and thank you so much.
Bye. Thank you.
Bye bye. Thank
Bye-bye.
you.